access to us. To start with, so welcome all, and just I will set the agenda here. Before I introduce Raghav, we would have about 5 minutes of introduction on Qualitas by Raghav, and then followed by he would cover a lot of time, about 15 minutes on the various use cases, and then from there on we would have an engaging, expect to have an engaging Q&A for about 10 minutes. So just to give you a brief on Qualitas, I'm sure quite a few of them, few of you might already be aware of Qualitas. It's a company, a startup which really enables companies to automate visual processes in manufacturing using AI and machine vision technologies. And as we have seen, and then, in fact, I have also seen, working with Incubate Hub, we have always seen that any emerging tech company, needs to be better at what they intend to do and continue to do better as they go along, right? And that is what we have seen really very much with Qualitas as well. While they help companies to do better using visual processes, and whether it's to do with testing and other things, uh, it is something that we have always seen that they have been doing and trying to see how they have been improvising as they go along. And just to Raghav we have today. Raghav, he is the founder and CEO at Qualitas Tech. So Raghav, the floor is yours. Kindly, yeah, go ahead. Yeah, Raghav.
Raghav,
Raghav, you're on mute.
your mic is in mute. Can you
Oh,
please
sorry about
unmute
that.
yourself?
Yes, yes. Hope everyone can hear me. So thanks, Uday. Thanks for the introduction. And hi, everyone. I'm really excited to be presenting to all of you. I'm going to go through this presentation real quick, and I'm also very eager to actually engage in a more of a Q&A. Now, before I get started, it'll be great if the audience could just type out in the chat window just which company they represent, what they do. So as I go along, I also have a sense of who the audience is. So that would be great. I'll go get ahead. I'll get started, and I look forward to seeing who's amongst the audience. So as Uday mentioned, our company Qualitas, primarily we automate visual processes in manufacturing. And what do I mean by that? What is visual processes in manufacturing? And basically it's there's a lot of human involvement in manufacturing, right? And then if you look at in a very fundamental level, humans are usually using the hands to do something, lifting things, assembling things, and that's really the motor functions of the human. The visual function of the human is when they see something and they take a decision based on what they see. And in a lot of cases, especially in quality control, we are dependent on humans in manufacturing today. Manual processes in especially quality control, or identifying, or counting, or any kind of visual inspection that happens. And so as manufacturing gets more advanced, quality becomes more important, and we want to increase throughput, velocity, etc. You can't rely on human for a lot of things. So just like the motor functions are being replaced today with automation and robotics and things like that, the visual function is what we try to replace in manufacturing, right? And so how do we do that? So we use primarily three main technology components. One is deep learning, which is the AI part, artificial intelligence, and a more specialized form of AI is deep learning. Then machine vision, which is nothing but camera acquisition, camera vision technology. That's image acquisition and image processing. And then we also have the industrial component, because we work primarily with manufacturing. We also have an industrial automation expertise. So that's the third area of technological expertise that we bring to the table. So all three together, is what we develop as a product. And so I'm going to skip through the details, but essentially, it's two basic components. We have something what is known as the factory floor component. So that is, there is a camera which is taking pictures of components in the factory floor. And then there is the, what do we call it, vision controller. That's the brain. So the cameras sends things into a vision controller. The vision controller takes the decision based on what it sees. Now, we also have a cloud application. So this is integrated, almost like an IoT sort of architecture. It's also integrated to a cloud application, where we use the cloud resources and compute for all the AI training, improvements, management, deployment, infrastructural management, things like that. So it has both on-premise component as well as a cloud component. And so what are the different modules real quick? So firstly, of course, to be able to see anything on a manufacturing line, you need a camera. Now, you can't just use any camera. I can't put a cell phone on an industrial automation line and work. So we do need a specialized industrial camera. And we have what we call as an eagle eye image acquisition module. And this is a very robust industrial grade camera mounted with lighting, optics, everything, in pretty robust, which you can put onto any factory floor and use it to acquire images. So this is a very configurable module, which, depending on your application, you can configure it and take the best images to be able to process it and take decisions. The second part of it is the vision controller. So it looks like a small industrial box. It's connected to the camera, and this is the brain, as I mentioned. So the camera is the eyes. This is the brain. The camera is taking pictures. The controller is then running our software to process those images to take real-time decisions. So this is really for online decision making. If you want to do quality control, if you want to read something, if you want to do print inspection, if you want to do counting, I'll walk through a lot of these examples, what all you can do with this. But this is the basic brain. And then we have the Eagle Eye Cloud application. Now, the Eagle Eye Cloud application is what trains the brain, right? And so what happens is you would log in to this cloud application and then, teach the system on what to inspect for, because this is a very configurable and powerful system that you can use to train pretty much, and I would say replace any human operation that's happening today. Whatever the human can do, the manual operation that is being done today in the factory can be completely automated using our Eagle Eye system. So how does it actually work? The first step, there is 4 steps. We call it the 4 I's: install, instruct, inspect, and improve. And I'll walk you through the 4 steps real quick. The install is, of course, the image capture. So you install a camera for image capture to capture what is known as training data, because you have to use these images to then teach the system what you want to do. So I have a small video. I'm just going to play how the system looks like. I hope you can
judgment
see it
of okay or not okay.
So
let's take a closer look.
So this is the camera, and then it's a box moves. You can see a strobe light, and that's a typical setup. So it's connected to, let's say, an industrial mount. So the lighting, the camera, etc. This is the typical setup. So that's the first step, installing the camera. The second step is then instructing. Now you have the images, but just with the images, it doesn't know what it needs to do. So here you need to then, these images, the training images, are sent to the cloud. And here's the instruction process, basically, which another short video of so yeah, so this is our cloud application. So let's say all these images are uploaded. Now you take this and then you annotate what is called tagging. So you tag this as, in this particular case, let's say it was to identify which part this was. There are many different parts and you want to identify which part. So you just, sit and tag it. And then what is known as neural network training, so machine learning. So then you select some parameters and then you, based on those examples, the system will learn what to look for in the in future. So to do the prediction. So that's the second step. That is the instruction step. So install, instruct. Now, once it's instructed, now you can inspect. Right? The inspection happens on this vision controller on the edge. So now you don't need the cloud anymore. The cloud is only for training. So once it's trained and then the trained solution is deployed, you can disconnect from the internet and it can automatically, autonomously run independently of the cloud. So this inspection sort of happens, you know, there is like a typical control panel right over here. This is a real-time user interface. You will see on the factory floor. Oh, let me show you the control panel. Yeah. Yeah, so it's usually enclosed in a control panel, which is more industrial grade, etc. Now, the last step is the improvement. So in order to ensure that you're getting 100% accuracy or 98% accuracy, whatever you need to do, you need to then correct the errors. So the system in the first phase will not be as accurate. You'll need to train it because there'll be new conditions that may have come in, which the system will fail to recognize. And then the improvement also can happen online. So it's very easy to take those failed systems and to reconfigure it to make sure that any failure is addressed moving forward. So what do so let's look at a few examples of how it can be used in industries. So one is print verification and reading. So let's say there is some label which is very hard to read, and you want to verify that the correct print is there and it is the right data, it is readable, especially in pharma, packaging, etc. They're very high speed. So it's very easy to sometimes have some misprinting or no printing or wrong printing. And you want to make sure that 100% of all the labels, all the packages are inspected with accuracy. So you can use that with very high speed. You know, in this particular case, we've deployed something in a lot of the FMCG as well as pharma sectors, which run at 180 parts per minute and much higher as well. Here's another example of a printing inspection. So this is for cigarette packs. And high-speed labeling. So it's not just so there's different kinds of like dot matrix print. So any kind of print which is printed on labels. Another kind of interesting common application that we see is defect identification. So in this particular case, these are taper rollers. So you can see that, you know, these have some tiny defects like these dent marks, scratches, you know, where the polishing or the finishing on these parts have not been completely done. Now, and these are again very high speed. And there's no way a human can check this 180 parts per minute, looking at all the different angles. It's not possible. So you have to automate using some kind of automation technology. And this is where the power of these systems will come in. Another example is counting. So in this particular case, these are piston rings. They're stacked over here and they're very tiny rings. Now, to be able to count 200, 300 of these is going to be very time consuming. And but with the click of a button and using machine vision AI, you can, you know, in fractions of a second, you can get a very accurate count. So you can verify that the number of piston rings in a packet is, you know, up to the right count that you wanted. Here's another example. So this you may be familiar with, refrigerators. So if you look at refrigerators, inside the refrigerators, there are many shelves, there are different compartments, there are a lot of, you know, like a manual, there's a egg tray, ice cube tray. So what happens, these are all manually inserted during the assembly process. And it sometimes happens that a part gets missed out because they're moving quite fast. When you're manually inserting it, the operator may miss out something. And then when it gets delivered to the customer, he says the shelf is missing or an egg tray is missing. The whole refrigerator has to be sent back. And it's a problem, big problem for the customer. So here, you have cameras, and in real time, you can identify that, okay, is all the components present? And at 100% accuracy, it's able to identify. So it catches anything that is missing and stops the line and alerts the operator to take action, to say this shelf was missing, or this compartment, or this egg tray was missing. Another example is in very complex casted. This is in automotive. So you have these. This is a small part, and you can see all these cameras, regular cameras, looking at it from different angles, and it identifies, very tiny defects like dents, blowholes, cast iron defects, and it identifies that and flags it so that it's caught. Again, in
Hey,
automotive.
Raghava, Amit here. I have a question. Can I ask?
Yeah, sure, Amit.
Yeah.
Could you tell
If you
me
go,
where you're from?
I work with Yodlee. Previously, I worked with Procter & Gamble, spent over a decade over there.
Okay.
And coming from, so it's very interesting use cases which you are showing. And similarly, I worked on something similar few years back in PNG. If you go back to defect identification use case of that cast iron thing. Now, in this case, I'm sure you must be using deep learning to be able to identify those defects, train the model. One of the usual problem which is which is there is deep learning needs huge amount of data,
Yeah.
and that data typically what we see in most of the industrial environment, the defect would be up to 1% max.
Yeah.
So getting image data for training the defects, various kinds of defect, and then enabling it into the production, there is catch-20 situation. Unless
Yeah.
you catch whole lot of defect, you cannot really train a model, and that all those captured defect, you need to tag those images,
Yeah.
right? Manually, which is huge, enormous task. At the same time, whenever you deploy, you cannot deploy a model with low level of accuracy and precision and lower recall.
Yeah.
So how do you overcome this kind of problem? Have you done some kind of, or this kind of implementation in some of those environments?
Yeah, we have quite a few. So that's a great question, right? So that's the main challenge with any kind of AI is the big data problem that you call. So we have to work with deep learning is data hungry, whereas the supply of data in especially some of these defective scenarios is very limited. So that's one of our specializations. So we do work with smaller amounts of data. So we have techniques to artificially create data, augmented, and then we also work with a large number of good samples. So it builds an understanding in its intelligence around the good samples, and it looks for deviations from those good. So even though you don't have too many defective components, you can still work with a large number of good samples and compensate for that lack of defective samples.
Okay. And typically, the manual tagging, if you ask a user, probably you would not get good training amount of data, right? Basically, a user might be able to upload just 10 images, 20 images. So in those cases, how do you really augment that data? Is someone really manually tagging from your side to train that model? Because each environment, each use case is different in this case. So you will have to customize those models, retrain and redeploy.
Yes.
So how do you overcome that challenge?
So we have a complete workflow which allows us to collect this data. So what we have like a data collection module. So in industrial environments are very unique in the sense that there's a lot of repetitive manufacturing. It's very skewed in terms of, as you said, there is 99% of it would be okay samples and very few will be defective, right? And so how do you actually collect enough training samples which represents all the different scenarios that you want to train for? So what we have is what we call is a data collection workflow, which is actually the first step of the procedure. So our project engineers, what they do is they program this workflow to actually collect the data. So it identifies that, okay, this is the variant that's running. So, and there are maybe 7 different variants. in that plant for a given part.
Mhm.
Now, and you can configure that you need 100 OK samples of this variant, maybe 10 defective samples of another variant, and you need it over 4 days. So once you install the camera and you deploy it, so using maybe a barcode reader or some kind of a, maybe the control system will tell you which variant is running, and that usually is predetermined. You know which variant is running before.
Yeah.
It is only that you need 100 samples of all those different variants. So once you know, what it does is it samples the data over a period of time. So it does it, a few in the day, a few in the night, and then you can also manually create these defective scenarios and pass them, and then tag it in the data collection module. So it starts to get collected and organized in our training system on the web. And from there, you have a limited set, and that is usually tagged and manually labeled by our data scientists. So we have a team of data label annotators, as we call it, a pretty large team. And so once you have the wide representative of these data samples, you can quickly annotate, and the number of iterations that you do from labeling to deployment and then retraining can be reduced. So we have all that workflow. And then towards the end, we also do the what do you call grading and accuracy verification. That's another module that we have. So we've kind of built in all those different steps into our cloud application in this platform.
Awesome. Thank you.
Yeah. So I'll go through this. Another thing is OCR. OCR is very common. So I think, a few minutes, and I do want to leave it for more questions as well. So we have been recognized in a couple of different scenarios, and we work with a large number of enterprises and industries, and across industries as well. And I think that's my last slide. Yes. Okay. And we are located in Bangalore. So
yeah. Thanks, Raghav. Really appreciate. That was pretty good. What I always feel is that if you could share what are those unique things which you have really progressed over the years, right? In terms of whether your cameras or whatever else is something where you have really used something which is a little differentiator. Then obviously the AI model is and other things we have discussed. But and second question I have is what kind of interests or traction you are seeing given the new normal? These are the two things which I wanted if you could cover.
Yeah. Sure. Yeah. So one is, where we have really specialized in is earlier we, as AI and deep learning started to gain popularity, we started to work on the software bit, and we saw that that was an area that a lot of startups actually are working on. They're quite strong in AI, the AI and deep learning model building and training. But we realized quickly that there were two gaps that we had to address when it came to industrial. And one is acquiring the data itself, right? And so it was not that trivial of a job to be able to even go and install a camera and to be able to acquire images very consistently and in the format with clarity that you would then be able to annotate and train and build AI models around. So we then spent a large amount of time, effort, and thought into building this camera acquisition module, because we wanted something very flexible, which we can quickly deploy when we had an installation to be conducted, and we needed it to be industrial grade as well. So a lot of times we would see that people would struggle and put, maybe web cameras or something like SLR, consumer grade cameras, and they're not really intended for industrial use. So that is one area that we really focused on, and we built, and that's the output of that was, what you see here as the camera module, right? So you can see different lighting, this arm, and you can quickly configure it, tune it to whatever angle. When we realized that, okay, not all the features were clear, with one angle, you can quickly change it and then mount it at another angle. Then all this had to be done so that it's also, robust. The second area, and this is, what Amit was asking earlier as well, is the kind of workflow. So we needed to have the entire start to finish. A challenge was it would take months for us to deploy and train a solution. And in order to scale, we had to really compress the time of how we started a solution and then we deployed it. And for that, we really built up our expertise around the web platform. And we wanted to use the power of the web. So the first iteration of, and there were two reasons for that. One is that AI training, etc., was earlier very compute intensive, and having dedicated training hardware on premise to do the training, etc., was not going to be very feasible. It's going to be very costly for our customers to have. So we wanted to take advantage of the cloud infrastructure for training. And the second is in able to manage these deployments. So you had, let's say, 4 or 5 different cameras in your assembly line. But how do you know what is the accuracy? Is it actually working correctly? Do you have visibility? How many defects are you seeing? How many false positives, false negatives? Is it working? And if you see false positives, how do you correct it? So it was very difficult to manage all these different deployments, because in an enterprise, especially most of our the recent project we're doing has 100 deployments across India, all the different plants. Now, how do you manage this? How do you know which one is causing accuracy issues, and how do you go and correct it without having to physically be there? So then we invested a large amount of time to build this web architecture, which allows you to handle these kind of deployments at scale. So I think those are the two areas which really sort of made a differentiator for us, and we were able to really take our services and solutions and to the next level based on these. So now we're able to quickly deploy, and we're also able to manage it at very large scales.
That was really nice sharing. I mean, really appreciate that. I think in the interest of time, I know we would love that. There have been quite a few questions, but I will just post just quick last two questions, before we get on to the next one. I'm sure, uh, next presentation. I think the time is almost due. What kind of hardware do you use for inference at the edge? Do you have any existing OEM partnerships? And the number two is, what is the accuracy can be guaranteed? Normally how much time it takes to train the solution to go into production? What is the speed image capturing can happen and all that?
Yeah. Good question. Yeah. So the inferencing right now, I would say the ecosystem and the technology on that exists today is very much optimized for training. There's a lot of options for training, especially in the cloud. Like all the cloud providers provide the training infrastructure. On the inferencing, it hasn't quite matured yet. So we work with both Intel as well as NVIDIA. And those are the two main horses in the race right now. And both of them are really working at warp speed to try to get their inferencing infrastructure, I would say, matured. And so all the ODMs would then build upon that. So we work directly with these partners, Intel. So using the Intel Open Vino infrastructure, that's some amazing work that Intel is doing. So we're able to optimize using 7th generation, 8th generation CPUs to really optimize our models to work at 1/5 the speed it would take without these optimizations. So that is one thing. Then also we work with NVIDIA and their Tensor RT stack, and both from a Jetson architecture as well as the V100 kind of Tesla architectures for inferencing. So it really depends on what is required. But right now we don't have one story or one sort of out of the box solution. We really customize it based on what's required, and we work. We are quite open in terms of who we work with. It's more around what is required for that solution at that given time. In terms of accuracy, here again, it depends, right? So if it's a combination of the complexity, the way, and the amount of data that you have. So, but I would say So far, all our solutions met or exceeded human accuracies, right? And that is the benchmark that we use, because it's not a number. It really depends on how if it's a very high speed application, the human accuracies today, it's very low. It's like 80%, 90%. So we're easily able to beat what is status quo today. So rather than give an absolute number, our benchmark is always what does the customer have today, and that's usually a human inspection, and we are able to easily beat what the benchmark set today with manual inspection.
Raghav, what's the usual cost of these systems? I would say system, since it is entire end-to-end setup. And how does it compare with conventional systems like Cognex or something similar, or maybe your nearest competitors?
Yeah. So, where we differentiate is we work with two sort of clientele. One is, our specialization is in the vision side, right? But when we work with end users to a manufacturer, let's say Procter and Gamble, they want the entire setup. And so there, there's some customization that has to happen around, what kind of automation is required. And we work with partners to do that. So there, it really depends on, what bells and whistles in addition to the vision that they need. But typically, if you're looking at a one camera deployment, the Eagle Eye system is the BOM cost. There's two costing to it. There's the bill of material cost, and then there is the software and the training and the deployment and the engineering cost to configure it, right? And it's usually a single system, camera system with just the camera is anywhere from $20,000 is around that range.
Got it.
Ballpark. But then if you have automation, control panel, services, then it kind of plus adds up.
Yeah.
So when it comes to, how does it compare with other competitors, right? So one is when it comes to deep learning and AI, there aren't too many players. So Cognex recently, they acquired a Swiss company, which is, does this, but they only develop the software, right? So ours is cloud enabled. So you don't need dedicated training hardware. You can get a subscription to a cloud service, and you can do all the training, and you're charged based on your the training resources that you utilize. So it's very easy to deploy, low barrier to entry. And the camera system, for instance, configurable, easy to install, no issues there, right? So that's, I think, the key differentiator that we have from other traditional players in this segment.
Okay, thank you.
Yeah.
Okay, I guess, thanks. I think we are just run out of time. There are some few questions. I'm sure, we will do one thing, Raghav. I will we will connect you up, quickly, because Mr. Chandrasekhar Raman also has a question. Quick one, you can complete that. Can you inspect for tolerance on dimensions, and does this system have stereo vision capabilities? If you can quickly answer that. Yeah.
So dimensions, so, dimensional engaging is typically not a AI use case. So what we do is we replace the humans. Dimension, etc., is using a tool like a vernier or some gauge, and we don't replace the gauge. We replace the human, right? So, so that's not something that's in our expertise. And
okay, we'll anyway. I do one thing? Maybe separately connect up, surely one-on-one, and then take that. Really appreciate your time, really, Raghav, and it was an awesome, presentation. And thanks for sharing the differentiators. Looking forward, we will connect up with you.
Pleasure, and I'll put my contact details in the chat window. So if anybody is interested, there would be.
Yeah, you can hold on to the presentation. Yeah. Anyways,
Thanks, Raghav.
Thank you. Thanks, Uday.
Thanks.
So I'm just going to put my contact details here.
Yeah. So thanks. I think next, moving on, we have Altizon. We have Dheeraj from Altizon, who heads their sales, and he's the one who is just joined in as well. Thanks, Dheeraj. Just to give you a quick one in terms of Altizon. Again, quite a few of you surely must be aware of what Altizon is into, but they are really powering digital revolutions by helping Industry 4.0 enterprises leverage machine data to drive business decisions, right, in the industrial IoT world. And over to you, Dheeraj. I appreciate holding on for a couple of minutes. I think. Yeah, you can proceed and give about whatever brief, or you want to interject your capabilities and brief to the use cases, but would suggest that you cover as many use cases, giving a brief of about 5 minutes on Altizone. Yeah, okay. And we'd have about a 5 7 10 minutes of Q&A, and
Sure.
that's what I think. Yeah, I
Yeah.
appreciate.
Okay.
Yeah.
Sure. So I'm just sharing my screen. I hope this is visible. And with me, I'm joined by my colleague Aditya Rikhari. We are part of the sales team at Altizon. And
Hi guys.
I'll let Aditya do the corporate overview, and then I'll take over for the demo.
Okay.
Thank you
Okay.
so much for the opportunity.
I
Aditya,
appreciate.
over to you.
Yeah.
Okay. Hey, hi everyone. So this is Aditya Rikari from Altizon Systems. So we'll just go through 4 or 5 slides which are not very text heavy. Taking you through what is basically Altizon, just introducing you to Altizon, and then we plan to do around a 15 to 20 minutes demo of our application specifically catered towards manufacturing, and then we can have 5 to 7 minutes of question and answers. We'll try to leave some more space for that. So I think quickly cutting to the chase, an introduction about Altizon. I think this slide pretty much captures a lot that we wanted to say. Altizon as an IIoT platform, was born in 2013 and has been recognized continuously for 2 years now. In 18 and 19 by Gartner in their Magic Quadrant as one of the 10 top IIoT platforms across the globe. The focus areas we work on are industrial IoT, digital operations transformation, a lot of digitization that happens in manufacturing, a lot of paperless to digital, IT OT integration, all the, basically the backbone of all kinds of improvement projects in the new digital era that manufacturing companies or OEMs which have heavy assets installed in their customers' premises, are is basically what is done by us, right? And it includes industrial IoT, capturing of machine data. It includes a lot of digitization of paper-based processes, integration of IT OT, as I've said, and machine learning analytics, right? The products, as we mentioned, I mean, so we have 4 products, so 3 are mentioned here. So I'll just go through quickly right now, and then I'll cover them in the architecture slide also. So Datonis is the platform where you have a multitude of applications. Then you have Mint, which is the manufacturing intelligence application, which is specifically catered to manufacturing use cases that we will be specifically focusing on for this demo and this presentation. And then you have a Datonis Edge Gateway, which is not just an IoT gateway, but a piece of technology which can actually help you run your applications locally, and all sorts of things that it can do. So we'll cover all of that. Vertical wise, I think we started from automotive as one vertical, but as we have grown, I think we have covered almost all verticals, which kind of sub verticals in manufacturing, not limiting us to only automotive, but going to chemicals, consumer products, building products, tires, metals, and also textiles, right? A sample of our customers, I'll not repeat it. You can all see it, like PNG, Dover, Arvind. So a lot of these customers are in India, but a number of these customers are also in Europe and, US geography. So as you see, PNG is something which we have kind of connected, 20 plus plants of PNG across Europe, right? SRF is an Indian customer. Their plants are in India. TVS is also an investor into Altizon, and we have connected a number of TVS ecosystem plants. You can go to the next slide. So, right. So as a digital leader, I want to, answer some of these questions with respect to my manufacturing and the data, related to manufacturing, right? So am I able to visualize my operations and kind of do what if analysis on my operations and see how things change if I change parameters. So essentially a digital twin. Am I able to get alerted for any anomalies with respect to historical data that I am getting, right? Do I actually have a tool which kind of gives me specific areas and points me to specific areas of improvement, right, which is data backed, right, on which I can take improvement projects and all of that, right? So and in the times of COVID and all of that, like I want to have a supervisor free plant, right? Only people who are operating, and maybe if people are not operating and robots are operating, only those guys should be there. If somebody is not operating, should not be there. And am I able to do all the supervisory activity that I want to do remotely, right? So some of these questions are to be answered first before we talk about all the bells and whistles and fancy things about AI and machine learning in manufacturing, right? That we can all speak about. But I think the journey should start somewhere around here when we see the manufacturing maturity across continents, so to say, right? So these are some of the questions that we want you to ponder upon, right, as manufacturing leaders. Can you go to on the next slide, Dheeraj? Right, so these are some of the focus areas which Altizon focuses on, and I will focus on the left side of the slide for this presentation. So we are talking about productivity, quality, maintenance, traceability and genealogy, and energy, right? So these are the 5 basically things in which our application is also molded into. Our whole data structure and a data lake that we will kind of be end up creating for you will have all the data which flows from the PLC, DCS, on the old OT systems as they call it, and the IT systems which include your quality management systems or ERP, or things which are related warehouse management systems, so IT systems, ultimately culminating into these 5 use cases, right? And once we have those 5, then we can kind of do either dashboarding, reporting around it, or which is called prescriptive analytics, to kind of predictive analytics, right? So like that is the gamut of things, but these are the 5 scope areas that we work in. Specifically, I'm like limiting onto myself to the left of the slide because this is related to manufacturing. On right hand side of the slide, what you see is something or some offerings that we have for OEMs who have their equipments and not the manufacturing plants, like players into wind energy, solar energy, players into solar batteries, assets which are outside of manufacturing, but kind of they want to understand what are the different parameters related to it. If you can move to the next slide. So this is a snapshot of what we have done across continents. I think we have so this is an outdated slide, but we have now around 150 plants connected across 60 odd customers, right, small and big, as we have picked them going in our journey for the last 6.5 years, right? And what you see is basically the benefits. Is a very busy slide, I'll not go through into all of that, but what you see is the gamut of use cases, the spread of the use cases, and the percentage benefits that we have basically on an average kind of yield got for our customers with respect to specific KPIs that they see. We've released a smart manufacturing report which basically kind of details this out vertical by vertical, and also a Gartner newsletter which is available on our website. If required, we can definitely share it with you. Do drop in a note. I'll in the interest of time, I'll just go ahead such that we have more time for the demo. Here's next slide. Okay, so this is the stack before we go to the demo, right? Such that there is an idea of what we will be showcasing to you. So first of all, on the left hand side, you see the Daytonus Edge Gateway, which is basically connecting all the different kinds of IT OT systems. So we have a ready-made set of adapters of 10 plus adapters of industrial protocols, which basically allow you to kind of plug and play, connect with your industrial systems, stream data to Daytonus Daytonus IoT platform, which is a cloud platform, but it can also be deployed on premises, can also be deployed in any kind of private cloud environment that you have. But we have a multi-tenant stack that we kind of offer by default. Then you have enterprise systems on the left also, which includes your ERP, CRM, BI, as I said, which also can be integrated to cloud. Then you have your Mint application on the right hand side, right, which is the third. So platform basically, so again, taking a step back, the platform in itself, takes care of a lot of things which are basically, technical use cases related to any kind of IIoT project, right? So event streaming, stream analytics, right? Device management, even your machine learning, notebooks or machine learning, model building framework resides in this particular platform. The rules framework resides in this particular platform. So, I mean, the platform is in itself, a kind of application which can be used in itself. But then, we've gone ahead and made certain specific applications. So Dayton's manufacturing intelligence application, which you see on the right hand side, which says traceability, OE, quality, CBM, energy, all those use cases is something that we have built for manufacturing. So here, all the manufacturing related master data, like, your operators and, man, machine, method, material, and every kind of thing that is related to manufacturing is resides here. And then you have, basically it's the end user interface for, for a manufacturing end user, who is using Dayton's stack, right? And then the latest that we have, got, the latest product that we have launched is something called Dayton's Business Intelligence. So what it does is basically, after you have created a data lake, so there are ready-made reports and dashboards and all of that you can do. But apart from that, if you want to, kind of democratize this data across your users and, ask them to build their own reports for analysis and all of that, so that can be done using the Dayton's BI framework. So you're not limited to the reports that we deliver. We want to, kind of ensure that, after we have implemented it once and trained you, you can kind of, go ahead, actually integrate more machines through the edge, stream more data on Dayton's, configure your machines yourself, and build your reports yourself. So that is the, do it yourself democratization of data leading to improvement is what we see. So how are we different from others, right? So, like, again, I mean, there are dime a dozen people who are saying that. Vidyesh, can you move to the next slide? I'll just cover the next slide and then you can. So, okay, so the last slide. So basically there are, I mean, I understand there are dime a dozen people who are saying that we can do IoT and all of that. So, I mean, it is basically a very multidisciplinary field as we have gone ahead, right? It's not like consumer IoT where you stream some data on the platform using some Arduino or, Raspberry Pi, and you can just visualize it and you can be happy, right? People want a return on investment at the end of the day. So I think these three things basically kind of, gives us the edge. So first of all, it's a stack from a technology point of view recognized, which has edge to cloud to manufacturing intelligence. As we shown, we have flexible deployment models, can deploy anywhere, right? The scalability is there. I mean, we have done deployments, which goes from one plant deployment to, like, 10 to 15 plants deployment, right? And so these are the comprehensive proven IT stack, right? Then is the IT OT integration, which is, kind of needed for a bedrock of any kind of IoT application, right? Whether it is integrating or SAP, Oracle, or Mitsubishi, Siemens, like, IT players or the OT players, right? As I said, right? So it doesn't really stop at, giving a hard coded non-custom rigid application. You have to have more, like, you have to have a framework for custom development, accelerators, where you can, have your paperless data. I mean, a data which cannot be, come through a machine or a system, but is manual entry. Can it be, like, converted into digital very quickly, right? As a, from overall process, right, point of view. And then from a business value realization point of view, we do not stop at kind of building the application and giving it to you. We follow a model called ABORT. So it starts from assess, build, operate, advise, and transfer. So in the operate and advise phase, you have, I mean, we have a small consulting team which helps you, along with some of our consulting partners, to basically analyze that data that comes, to you, right? Help you build those data science models, basically go along that journey with you, because there'll be no plug and play data science models beyond certain models. For, let's say, predictive maintenance, you'll not have models which will be very specific and very typical models. It will be unique as you go from manufacturing to one manufacturing plant to another, right? And therefore some of these things basically allow our clientele to derive that ROI which is required for them to kind of do POCs and then subsequently scale up. So the amount of scale ups and the amount of customers with which we have done scale ups kind of speak for themselves. Now I'll ask Dheeraj to basically take you through some of the application or the platform that I have just spoken about. We'll start with the application first for a better context for you. So manufacturing intelligence as an application. And then once we have done that, then we can go to, we can see our platform, our edge gateway, all of that, in whatever time we have, and then we can take questions.
Yeah, thanks, Aditya. I think, Dheeraj, if you could quickly go through in the interest of time, I appreciate, because I would love that, if participants can, whoso wants to ask questions, can unmute themselves and ask questions so that we cover it fast. Thank you.
Sure. Thanks, Aditya. Okay. So as we discussed, so this is the manufacturing intelligence application, which is what the end users actually see and use, which the end users will include your right from starting with your operators, supervisors, production in charge, production managers, production heads, and right up to your CXOs. So what you see here is so right now 3 o'clock is the shift change that we have here. So what you see here is a management dashboard, which indicates your key KPIs that management is interested into. And the application has five workspaces: productivity, condition-based monitoring, quality, energy traceability, and work order. So just in the interest of time, we will go through a couple of the key dimensions. So for example, the productivity dimension, right? So any kind of discrete or process plans, productivity is definitely the key to any kind of performance. So what we have done is all the data that we capture from machines is actually translated into your key performance indicators. These are our standard dashboards and reports, which are quite common across discrete manufacturing, and as well as we can customize these for process. So what you see here is a complete set of your OE, the APQ, availability, performance, and quality calculation, which then in turn help us arrive at the real-time OE. So the values that you see here are for the real-time data from the shop floor. And then what we actually do is we actually build a production timeline for any assets that we have connected, and we can actually look at the data at a cell level or at a work center level. We support two dimensions here. So so essentially what this is a complete timeline of a machine for shift A from yesterday's data. And any red green slots will actually mean that red is a productive slot, and sorry, green is a productive slot, and it indicates what part you are manufacturing at that point in time on this particular work center. And a red will indicate a downtime slot, and a TPM code could be assigned to this particular downtime. A number will indicate like a tool change or a TPM code. So like this, we build a complete timeline of any machine, and then any kind of downtimes will be captured, and a TPM code will be assigned by the operator to get into the availability part of it. So what we then do is help you with a with the productivity analysis dashboards, then the downtime analysis reports. So all those reports are built. Then what you also see is the production quantity into number of cycles. So within how many cycles the quantity that you have built made at an hourly level. And and this is an indicator, a quick indicator of what are the major minor stoppages of the machines or at a cell level. So what are your top three
Amit
losses?
here.
Yeah, hi Amit.
A quick question. These are good dashboards, but I'm just wondering, do you need at the bottom of it historian or line event data system before this, or this is directly collected data from PLC, and then it is you who is processing the data and eliminating the need of line event data system?
Yeah, that's exactly. It's the second one that the stack that Aditya, I mean the slides which we showcase. So we have a edge which is a software gateway which will sit inside your premise software inside your factory network, and we will take the data from the PLCs directly. We talk to the PLCs, and then from the PLCs we actually yeah, and from the PLCs we will get the data to our platform where we will build the manufacturing data lake. So,
So
and
Dheeraj, I'll just take that question also. So, sir, I mean, to answer your question, basically, Daytonis IIoT platform that we have is a historian in itself. So we call it. I mean, to the people who understand the historian jargon, we tell them like it's a typical OSI Pi on cloud. If I have to tell you like that, right? So it's a
Yeah.
historian on cloud, and on top of that, you have an application which you are seeing, for Daytonis Mint. So we do not need any historian, we do not need any PLC also. Actually, typically it can also work with sensors, but typically PLCs will be available, so we harvest data from the PLCs. If you already have a DCS SCADA or a historian and there is an OPC DA availability there, so we won't actually touch your process and go to the PLC level. And in that case, we'll take the data from the OPC DA. So that is a different architecture that we can kind of enable.
How do you eliminate the need for going to cloud? Or rather, let me rephrase my question. In cases wherein you need low latency, you may not be able to use cloud infrastructure or Daytonis directly.
Correct.
So how do you handle those kind of use cases?
So yeah. So Dheeraj, can you go up on this edge?
yeah,
So sir, this is Daytonis Edge Gateway, right? Can you go to activity, Dheeraj? Activity.
sure.
Okay. So Daytonis Edge Gateway, in the sense, sir, what you basically no. So you do not have to. So sir, what happens is basically in Daytonis, so the Edge Gateway is sitting on your premises. So this is the Edge Gateway that Dheeraj is showing you. So it like that, there are 3 or 4 things that it does, right? So first is like securing the data packets. Second, the first and foremost thing is like kind of having a set of adapters which are there. So CSV adapter, Ethernet IP adapter that you kind of see in the services on the left hand side, that are ready-made adapters, Profinet, Modbus, MQTT, all of that, right? Second is it buffers the data if there is no connectivity, and then sends the data to cloud. But if you need a use case which has lower latency and all of that, what you can do is actually execute. So you can see here active rules, cache rules, ML models. So what you can do is you can train your ML models, rules, and all of that on cloud, and then push those ML models and active rules on the edge to basically examine your data, streaming data through those rules at the edge itself to get an alert, right? So that is for the alerts
So
part.
you would not send that data to the cloud.
I won't send that data to cloud. If and then I can also actually control. I mean, it can also work as a PLC in itself. So it can also control the machines if needed. It can write back to the PLCs and all of that basis triggering of a rule. That can be done through Daytonis platform cloud, or it can be done through on-premise Daytonis Edge Gateway. What we can also do is, and which is like very rare in the market currently, is what we call as Edge plus plus, which is basically if the internet kind of breaks, then I can also spin up a UI like Daytonis Mint on the edge itself, right? It will be a limited UI to actually, you will not be able to see, of course, 1 year, 1 year data, which is, historical, but let's say a week's data or that shift data or all of that, you will be able to see in that UI without the internet also. So if the internet breaks, if you're in a remote location, you can actually spin up a UI locally through the Edge Gateway. It's called Daytonis Edge++ that we have launched. So, we do not need, in that case, the platform itself. But the platform, of course, will be needed once you have to like examine and analyze historical data, because like 2 years, 3 years, 10 years worth of data will not, be residing on the Edge. Because Edge has a store and forward architecture. So it forwards the architecture, it forwards the data, and then it cleanses the data once it has stored. Once it is forwarded. Just to answer your question.
Yep. Thank you.
Yeah. And just to add, so this is how we have a concept of things template, which are nothing but your digital twin, where all the properties are defined. This is on the Datonis platform, how we model the assets, and for every asset, then it will be a part of the same thing template. And what you see here is a time series data that I capture from the assets. So all the properties and the events that we capture, so we can go up to like right up to millisecond level for critical assets, and up
Yeah,
to
so this
like a
is a
minutely
historian
level.
basically.
Yeah, so this is how that data would then be captured, and then using this information, say a job dot value or a machine dot status, then gets translated into this timeline that we have. So a job dot a machine status 0 or 1 will mean this is a productive slot, and a red uh, 0 will mean it's a downtime slot. And once we have these dimensions, then we can calculate the OE, and then by monitoring your cycle time analysis and so on, we can actually bring in a lot of productivity improvement. So our standard benchmarks, as was seen in the slides, was like at least 15 to 20% productivity improvement is what we can definitely achieve by analyzing the data. And then this is our data based changes that we propose to our customers.
So Dheeraj, if
So
you can go to
Awesome.
reports and just show the kind of reports that we have,
yeah,
uh, if no, in the reports tab.
okay, yeah, sure,
Yeah.
yeah. So
So
along
here
with that, yeah,
productivity,
correct.
you have all these 5 kind of reports. Then you have CPM. Acha, okay, you have shown
Yeah,
this
yeah.
already.
Yeah,
Correct.
so we have productivity analysis, wherein you can actually select a custom date range, like you can actually visualize data for a year or so, and then do a comparison, shift wise comparison. What are your downtimes, production variation, shift level variation? So all of that can be done as a part of productivity analysis. And you can also do downtime analysis, which is nothing but which are your primary major downtimes by category. What are the top reasons and the top work centers? Which are the work centers which are uh, giving most trouble, and then a lot of slicing and dicing of this data can be
Correct.
done. Yeah.
So Daytonis BI that we have, as I was telling, once we have the KPIs defined. So KPIs are availability, performance, quality, OE. We also have MTBF, MTTR, and all of those kind of things. Once we have everything on that, then custom reports can be built on Daytonis BI using drag and drop framework. So that is not a problem. So this is MTBF and MTTR report which Dheeraj is showing
Yeah.
currently.
I
So
think,
yeah.
yeah. Sorry,
So
in the interest
yeah.
of time, I really appreciate because I can understand, Altizon, which has evolved over so many years and having very comprehensive solutions. I'm sure, you would love to have one-on-one, to see that if anyone has any further real deep dive questions and understand as to what is in it, what are the low-hanging fruits anyone can adopt and how it scales up and how it can be adopted. Maybe we can take it offline if it is okay, Aditya and Dheeraj.
Yeah, sure.
I think we would love to surely have get you connected. If you could share your contacts over here in the chat, or otherwise anyway we will connect up.
Yeah, sure.
Unless anyone has any last question, because I need to then wrap up otherwise. Yeah, if someone wants to unmute and ask, else we can. Close. Really appreciate, and I think, I know the time was just not as sufficient. I'm sure, looking at the kind of scope and the variety of solutions which you have. But I'm sure, people would have got a good feel of how, one can really leverage from this whole solution stack. And given the thing that, needless to say that I'm sure your solution should be quite agnostic to the PLCs and other data or connectors, right? Over the years,
Right.
you would have surely connected and made it comprehensive enough, right, Dheeraj?
Yep.
Yep. Yep.
Appreciate. So great. I think thanks very much. Thanks everyone for joining in. And if you have anything, you could actually reach out to us. My email ID is uday@incubatehub.com. I will also post that in the chat.